Aging is an enduring mystery of science. Hi, my name is Mateo, and I myself am on the cusp of turning 21 years old. To be honest with you, I couldn't be more terrified. See, I've always set apart 21 to be the special age, to be a stepping stone in my life, marking my transition from adolescence to adulthood. I think a lot of people think like me. Many people, I believe, attribute certain ages with checkpoints in their lives to serve as heuristics to mark their passage through time. This is all an effort to cope with a process we all undergo, which is aging. But I ask you to reflect, what truly is aging? Is it the accumulation of those checkpoints, the transition from one checkpoint to the next? Or is it more simply the wear and tear of time on our bodies? The truth is, while science is closer than ever to answering that question, we are still unsure of what aging fully entails and the mechanisms that work behind it. One thing is for sure, though, aging is at the forefront of modern media and science. Here alone are a few examples of popular movies that depict the concept of aging. Of course, they add a funny twist of reversed aging or the stoppage of aging altogether, or accelerated aging for some reason. And while these are marvelous ideas, they tap into the biological need to fight aging. In fact, this man took it to the extreme. I keep seeing this post of a man, a millionaire named Brian Johnson, who invests millions of dollars yearly in order to slow down his aging process and reverse it through different exercise routines and diet regimens. Now, while diet has been positively associated with aging, we are still fully unsure of how aging fully works. Recent research, that being said, recent research has shown that there are primary hallmarks that can be used as heuristics to understand certain mechanisms associated with bodily decline. And so, today I'd like to walk you through one that piqued my attention, known as telomere attrition. As you can see, it is a primary hallmark of aging. Before I can do that, though, I'd like to walk you through what telomeres are and what telomere attrition even means. So, without further ado, what are telomeres and why do they matter? Well, telomeres limit the number of times cells in our bodies can divide, and that in itself protects the genome and helps our bodies prevent cancer. How does it do this? Well, telomeres consist of repeating nucleotides in sequences of TTAGG, which bind to a set of protein known as shelterin and protect DNA by forming a chromosomal cap. And the way it protects DNA is by making sure that throughout cell divide, the cell doesn't destroy some genetic material. You can think of this as when I'm sure you've used a printer in the past and you've messed up your margins and the printer printed halfway through a line, which gave something that kind of looks like what is on the left. Now, a quick way to fix that is to fix the margins and make sure there's enough margins so that the printer doesn't print on the text. I think that's what telomeres are kind of are. They act as caps, chromosomal caps, which prevent the genetic material from being destroyed. However, upon each cell divide, the telomeres shorten, and that process is known as telomere attrition, which is portrayed in these photos. Eventually, there is no more telomeres, and what happens then? Well, the cells stop dividing. You can think of it as a candle slowly getting smaller and melting away. Eventually, the flame puts out. In a similar way, cells go through apoptosis or senescence. And what essentially that entails is the cell either becomes quiet and inactive or it just dies. Now, some cells, you might tell me, that are not somatic cells, like stem cells or hematopoietic stem cells more specifically, need to consistently proliferate and divide over and over again. So how do they fight this telomere attrition, which is their biggest obstacle to dividing? Well, the body engages an enzyme known as telomerase, which adds sets of nucleotides to the ends of those chromosomal caps to lengthen telomeres. You can think of it as adding more wax to a candle as it is melting. However, this process is imperfect and doesn't fully replenish the telomeres lost. Therefore, aging is inevitable. Now, you might ask me, Mateo, let's just inject people with a bunch of telomerase so that they don't age. And while you are a bright mind, I tell you that won't fully work. Some researchers tapped into that line of thinking, though. In fact, they tested telomerase on mice, and they showed that telomerase reactivation can reverse tissue degeneration, reverse aging. The problem is this research was done on cancer-resistant mice. See, one thing with telomerase is that whenever you tap into cellular division, you also tap into uncontrolled cellular proliferation. And the problem is that that entails cancer. See, humans are not cancer resistant. So while these mice don't have this issue, we do. And so telomerase could just create a bunch of other problems which are more problematic than aging. Now, not all is lost, as telomere attrition studies are still very important in understanding the process of cellular decline and might still hold the key for the reversal of aging. In fact, one thing that is important to note is that we have significantly raised our life expectancy, especially in the past 100 years. In 1820, our life expectancy was 30 years old, and today it sits at 76. Now, we've hit a flat line, while aging and age expectancy has risen a lot in the past few years. It is now slowed down. And so you might ask me, how do we know that we can even crack aging as an issue? Well, I introduce you to this jellyfish. This jellyfish might very well hold the answer. This jellyfish is known as planula, and it undergoes a very specific process known as transdifferentiation. Whenever it detects some kind of damage or starvation, it can reverse its aging process to go in earlier developmental stages. Now, why is this important? It's because I think that aging is very much within the grasp of humanity, that we might be able to extend our age significantly more than we already have done so. And so I find all of these findings very promising for what the future to come, especially considering that modern society has students studying very late for careers such as being a doctor, like myself. I'll be studying until I'm probably well into my 30s to be a specialized doctor. It is good to extend our lifespan, to then live longer and be able to accumulate those skills. Overall, I think that the future of aging is very promising and hopeful. Thank you so much for your time today.